The way electricity is generated is changing. The way networks interact with assets will need to be managed differently. As the grid becomes more complex, insights from data and digital tools will be at the center. Camlin is at the forefront of the electric power industry with deep expertise in monitoring, diagnostic software, artificial intelligence, and machine learning, together with a huge bank of knowledge of assets and networks from over 40 years. We're now growing our office in Belgrade with opportunities for software engineers, data engineers, and machine learning engineers. Visit us to find out more.
Hello everyone, welcome back. Hope you had time to get some refreshments since we're diving right back into our program with our next talk with the title of Predictive NPS, a ML tool to increase the coverage and impact of any CX program. Before I announce our next speaker, I would like to just mention to the people following us online, feel free to ask questions in the live stream chat. Our team is monitoring the chat and your questions will be asked and read. Just feel free to write them. And without further ado, because this session will actually have a QA session afterwards, after the talk, I would like to announce Martin Dimov and call him to the stage to start his talk. Martin, thank you.
Thank you. First of all, thank you for having me here. It's been a great pleasure to perform in front of peers and in front of the data professionals. I really enjoy that. I've been planning to come to this meeting for quite some time, but unfortunately the COVID came, so we had to stay home and do different stuff. But one thing that is very important is that we never stop working and doing things with the data and thinking always about how to improve our applications, how to manage the huge amounts of data and different challenges posed by the business. My talk today is actually quite practical. I'm gonna introduce you to a solution that has been in our portfolio for quite some time. Actually going through a very practical problem, and we also have very practical solution, as I said. I'm going to talk about a very common problem that most of the industries and most of the companies nowadays have in the business. That is the customer experience. Customer experience has been in the agenda on a large company, especially subscription-based industries, for quite some time. Simply because nowadays it's not very common, and it's not always enough just to have a good product, and to distribute it to as many customers in order for a company to be successful. But it also means that companies should basically feel the pulse to their customers. Try to be as loyal to them, try to retain as many possible customers for their business, simply because it's very difficult and it's extremely difficult to basically have the cut down on the cost, to cut down the and to increase the revenues. Now, customer experience especially is measured in a various way. Maybe you heard different measures and different KPIs. Today, I'm going to talk about a measurement called NPS. Now, I'm sure many of you know about the NPS. It stands for Net Promoter Score, and it's one of the most important measures about how customers feel about you. You've probably seen that and probably experienced the NPS questions and then the NPS metrics on yourself. Every time you go to, for example, in your mobile operator and you're dissatisfied with something, you receive this small question via the text message or any other way on a scale of 0 to 10, how can you satisfy it, or how can you introduce the company to your peers or your relatives. It's 0 to 10 scale. Basically, it's one of the most common, as I said, most commonly used measurements. But one of the problem is that not a lot of people actually answer to that. I'm sure that many of you, once received this question, they deleted it automatically and never bothered to answer. But based on this question, the NPS was basically introduced into early 80s by Bain Company, and it's been in practice ever since. Now, the NPS actually divides two levels of satisfactions: the detractor, the passive, and the promoter. Each and every of those has a specific role within the customer domain of a company, because it's basically that you can imagine that detractors are actually the worst part, the people that are dissatisfied, and people actually that dissatisfied tend to churn, tend to leave the company, and it's one of the major problems for the companies, simply because that reduces the revenue, reduces the customer base, reduces everything that the companies actually strive for, especially, as I said, in the subscription-based industries. Now, detractors being a very essence of the different programs that company has. You've probably heard about closing the loop, voice of the customer programs, and all these. So all these programs have one thing in common: how to identify the customers that are dissatisfied and what to do with them. Now, you may ask yourself a question: why do we even care about the customers that actually are leaving the company? Why should we basically just leave them? They're not loyal to us. Now, there was a very good paper on Harvard Business Review saying that it's 5 to 25 times more expensive to get a new customer rather than retain and keep the old ones at you. You can imagine that companies do a lot to identify and to basically do a lot of campaigns and a lot of efforts to retain their customers just because of that. Now, as I said previously, only a few people actually answer to this question, and this is part of gathering different information about the customers, directly asking them. But only 10 to 15% answer that, and that's a very huge problem, because how can a certain program or a certain initiative of a company could be effective as you don't know all of your customer? You can cook a good meal if you have only 10 to 15% of the ingredients. You cannot go to a journey if you know only 10 to 15% about the map. Now, you probably remember one of the latest Star Wars movies. Everyone from the rebellion was searching for Luke Skywalker, and they only had a piece of map where he might be sitting. But of course, they didn't have the bigger picture, how to actually locate it in the universe. So this is probably a very simple example and very common to how companies nowadays react when they don't know what's happening to their customers, and how can they identify those that are actually at risk of leaving the company. So identifying those, bringing them to a certain level of awareness is actually has been one of the problems that many companies has. And we as data specialists and experts in the machine learning, we actually come to a solution that not only identifies the customers, but they could give you dissatisfied customers. But it could also give you 100%. Yeah, that sounds quite ambitious, but it could give you 100% coverage of customer satisfaction programs on the company, using machine learning, using predictive analytics, using a automated tool, an automated sequence of production line that I'm gonna show you in a minute, simply by applying machine learning techniques, gathering information about the clients, bringing that all into big pipelines, training the models, and then yielding results about customer satisfaction in a certain way. Now, this particular product, we call it pNPS, or Predictive NPS. As I said, a sequence of models that collects data from different sources, puts them into one place, and doing the modeling phase, doing the prediction phase, and getting back information back to the customer's database. Now, I deliberately avoid using very hard terms because you will hear them in a while, because I'm going to stop talking and I'm going to play a video on you that we decided to do it this way, simply because it's a lot more technical, and I actually could basically lose a lot of information on the live talk. That's why we want to play a video. But before that, 3 benefits of having this on a client's level. First of all, this particular tool increases the NPS coverage and provides an add-on layer of different levels of customer satisfaction and customer experience, providing the most important factors that influence that, providing the companies with different leverage and different buttons and tools that they can apply, giving and knowing the information about their customers. It also lowers the churn and also brings more referrals to the company, because satisfied customers tend to be very powerful source of getting new customers on board. That actually also brings upsell and cross-sell. One and the same customer could basically buy more products, be more successful to you, and so on. And finally, satisfied customers are more proactive. They give more efforts to keep their process and to keep their satisfaction going. As I said, they refer to other peers, to other people. They refer to other customers, and they basically are one of the the top level that every company should want. Now, if we can see the video and the actual technical parts that I promised you at the beginning, and after that, I'm gonna be here for any additional questions.
The model uses all available data on customers and account level, inclusive of behavioral data and operational data, CRM, operations, usage, interactions, complaints, tickets, billing and financial records, customer experience feedback data in terms of NPS, customer satisfaction or equivalent, dedicated survey research data, which could be transactional or relationship, historical records of interaction and feedback. The entire modeling goes through 5 distinct stages that are interconnected and interdependent. Data environment design. This is the most creative part of the whole process. Here we make a thorough data audit and data description. We define data exclusion rules, look closely at potential classes that we want to predict. We also make an extensive data mapping, which all goes into master data file design, develop model validation technique, and design the model performance blueprint. Data preparation. During that phase, we start by combining all data sources and all variables, a tedious process that considers all variable specifics on the lowest granularity level that allows aggregation. Closely followed is the variable recording. We transform categorical values into dummies and apply additional aggregation on numeric ones. A common practice we apply also includes variable imputation, that is replacing the missing values, using a separate model or other simpler data augmentation techniques. As a result, we end up with a huge data file, sometimes accounting for more than 3,000 variables, which is ready for the next stage. Descriptive analysis. During that stage, we apply all standard statistical methods that generally summarize the distribution of the raw data. By applying correlation and vintage reports, as well as all known types of statistical testing, we look for similar variables which could be eliminated if closely related to others. We prefer Bayesian methods such as factoring for more robust results. Apart from that, we look at how good all variables explain the variance in the target variable and the classes. Those with higher than usual impact are being penalized so that we get a sort of diversity when it comes to variable predicting the NPS. We do not want to put all our eggs in one basket. At this stage, we also look into different groups and subsamples of the population. If there is a significant indication of increase in model performance for different segments over a single major model, the entire modeling stage is split into separate populations for which separate modeling processes take place. Predictive modeling. Next, we start by application of standard data science approach. We split the data into training and testing. Based on the model validation plan we've created in the first stage, we determine which models to use and how to define and tune the specific hyperparameters. We usually start with a simple linear model so that we could have a starting point. It is a benchmark used to get our bearings with the other models we develop. The linear model is the one we like to refer to as a saturated model. Then, we apply penalizers based on variable importance and predictability. Further, we apply nonlinear models. We start with bagging and boosting methods, random forest, LGBM, and etc. And normally end with neural nets of different type, most commonly feed-forward fully connected with L1 regularization or LSTM. All of these are individually trained and verified, and their performance benchmark against the saturated models. The one that proves the best wins the race, and it's used for main prediction. Model evaluation. The target variable is a binary outcome derived from the NPS, where definition of super detractor is NPS values between 0 and 4, but definition varies. On the right hand of the equation are those variables that prove to have the highest impact on the NPS. The model performance is evaluated by the area under the curve or Gini coefficients. We also tend to look at the precision and recall. We refrain from using the accuracy since in most cases we deal with very low percentages of cases we need to predict. The preferred model would ideally perform the best, has lower complexity in terms of implementation, and would be easily adjusted for scalability. A final model performance aspect that is worth mentioning is the variable importance. The approach for calculating includes two methods: analyzing different sets of variables via combinations of linear models, or using Shapley additive explanation, also known as SHAP. These are model agnostic, which means that they could be used for different modeling techniques. The reason behind the two-method approach is the ability to compare importance with another type of model, for example, random forest, GBM, and so on, with less bias and hopefully with better performance. Empirical probability calibration. When performing classification, it is often desired not only to predict the class labels, but also to obtain a probability of the respective label. After the modeling is completed, the predictive values represent only a rank that could only be compared between predictions coming from the same model. Thus, they are not probability, nor they can be compared to values coming from other models, or compared to any of that metric for that matter. The predicted values are simply ranks that tell you that one order has higher probability of having been made by super detractors than other. What is behind the actual probability cannot be stated without an extra step of the calibration. The well-calibrated empirical probability gives you a high level of confidence in the prediction and its meaning. Some models can give you poor estimates of the class probabilities, and some even do not support probability prediction. In other words, the calibration represents a model with one independent variable, the produced score, from the selected model, while the dependent variable is the actual observed event rate model or some other close related event that in this case could be the NPS estimation. Now let's look under the hood. The whole technology stack gravitates around three main modules. Backend module, the actual data modeling procedure that we just talked about. API module, which connects and implements different algorithms for individual services implemented and exposed to the end users as endpoints. And finally, the database module, which holds the entire data stack, not only the raw data coming from the uploaded dataset, but also the outputs of different stages described previously. All the three modules communicate seamlessly among each other, which makes the whole production line going smoothly and in parallel. It all starts from the development environment, where a team of data engineers and data scientists are working on developing the entire code stack for the application, considering specific data and requirements which vary from client to client and from project to project. This initial phase is particularly important and takes a lot of creativity and planning to ensure the seamless execution of the next stages. Once ready, all code and setting files are pushed through Git protocol to dedicated Bitbucket repos, which hold only the latest version of the uploaded files such as Docker files, Kubernetes config files, etc. Thus, we ensure that the subsequent process uses the latest version of the files without the need of adjusting the actual API manually. On the other hand, it also enables different changes in code to be consumed without the need of redefining the whole stack if sudden changes occur during the actual execution. From there, all callbacks are attached into the pipelines through a useful tool called webhooks. The CI/CD process are completely automated. The second synchronization palette, which is securely connected with dev environment, is the Docker Hub. There are a series of containers and container settings and images stored so that every time the actual API is triggered, a new container, that is a virtual machine, is built with the same shape and size. In fact, the Docker Hub contains instructions and has a similar purpose to the Bitbucket, with the only difference that it contains images or snapshots rather than code. In general, when not in use, the production shuts down all containers so that no resources are to be spent in vain. The only available resource, which is active at all times, is the one holding the database, so that no data or progress is lost under any circumstance. The database is built on Postgres and serves three main purposes. It stores the raw data provided by the client as an ultimate source of truth, the model performance diagnostics, scoreboards, results, and final scores, which is the ultimate output we all are expecting from the model. The database has multiple endpoints which establish connections to external sources such as clients' databases or internal APIs for data manipulations and modeling. It could also be connected to a dedicated visualization tool which consumes the data outputs. It also resides in a separate container managed by the Kubernetes cluster. To connect the three different modules, we use a series of deployment pipelines and predefined commands, all aligned in Jenkins automated server, which also resides on a separate Docker container. The Jenkins server contains dedicated instructions for every pipeline, stage of the cluster deployment process, and it serves like a switchboard. Every action needed is recorded as a set of instructions in the pipeline that are triggered in a predefined sequence or upon termination of adjacent processes. For example, you start the API service deployment upon finishing the cluster deployment process. Jenkins also provides ways to optimize the entire process and cut down costs and time by turning on the required modules and switching off the different instances when not in use. The entire process starts by building a service cluster in the cloud. We decided to use AWS, but the entire process could be easily implemented within any cloud-based environment, even internal client's domain. For setting the environment, we need AWS cloud resources and deploying K8s clusters with KeyOps Kubernetes operation using a shared VPC, Internet Gateway attached to the VPC, and an S3 bucket for volume storage. The cluster is managed by KOPS, which builds the necessary number and types of machines by taking the instructions from Jenkins and runs the pNPS services on the cluster machines using the respective Docker images from the Docker Hub and source code from the Bitbucket repos. The number of nodes in the cluster depends on how many active projects run at a certain period of time, plus one master node, which contains all processes and calculations relevant for all. The system also allows different nodes to be located in different cloud services and geographic areas based on client security protocols and requirements. The master node contains API server, scheduler, and control management system for resource optimization. The other nodes contain separated databases with specific data, modeling instructions, and individual settings. Thus, one engine could be used for different modeling purposes, different clients, even different prediction tasks if all of them follow same principles as the others. The entire process is over once all variables are processed, data is consumed, and the database is populated with the most recent and most accurate predictions for the entire customer base. A separate optional module represents the process output, model performance, variable importance, and overall modeling diagnostics through series of visuals and logs which are easily downloadable and accessible by product consumers. Additionally, we provide accuracy report and summary of findings on aggregate and customer segment levels.
Your voice always sounds weird when you hear it outside of the, it's horrible. Anyway, thanks for watching and thanks for hanging and seeing all this stuff. Now you can imagine why I actually pre-recorded this, because there was no way I can reproduce this right now live in front of you. Anyway, any immediate questions, guys?
Hi, everyone.
Yeah.
Yeah, okay. Just a second, let us turn on your microphone so you can ask.
What are the types of metrics you are trying to capture?
Sorry?
What are the types of metrics you're trying to capture?
Methods.
Metrics.
Metrics.
Yeah.
As I said, there are different data sources. First of all is the survey research data, obviously containing the information about a certain chunk of customers that's been answering questions about their customer satisfaction level. There is also a couple of other databases coming from the client side, for example, CRM, billing system, any other behavioral, like for example, upselling, cross-selling, how people actually react to different campaigns. All this information is actually stored, and once you have this on a customer level, on a let's say different customers or different account level, the whole information is gathered within the customer domain, and then it's transferred to the whole pipeline as you see it. And then it's stored in a database, and the whole process starts as you saw it.
Thank you. Very interesting.
We actually have one question from our guys that are following us online. You mentioned that it's around 10 times more expensive to gain new customers comparing to trying to hold on to existing customers. Has that always been the case in your experience? And can you give us a bit more insight into the source and origin of that info? And can you comment a bit about that?
Actually, yeah, this is one of the papers, as I said, from Harvard Business Review. I read recently. It's actually 5 to 25 times, really depending on the industry.
Oh, wow.
But it's one of the in this particular stack, you would add all the commercial efforts, all of the campaigns, all of the product alternations, all of the things that basically marketing companies and the companies in general do in order to attract more and more customers, rather than trying a bit more effort, putting a bit more effort to retain those that are already their customers. There are, like, in the industry, there are two main types of marketing, as we call it. So the standard Kotler marketing actually says that you create a product and then you spend a lot of money and trying to attract as many customers, as many clients to that product. Whereas the predictive analytics and the CRM analytics says that you focus on a group of customers and then you try to create the most powerful and the most effective product for them, and it's times more effective, than very much more effective rather than the first option.
Yeah. Okay. Thank you for that answer. I'm sure there are many more questions for Martin, but unfortunately that's all the time we have for now. Feel free to maybe contact him, email him, or something like that with additional questions. I would just like to thank you, Martin, for holding this talk, and I'm sorry your colleague couldn't make it with us. And here's a little certificate of our appreciation for holding the talk.
Thank you. Enjoy the rest of the day.
See you. Don't go anywhere, guys, since our next talk is about to begin immediately after the promotional video.